Welcome to This Explainer. Today, we're diving straight into one of the most enduring, fascinating, and, honestly, downright baffling cold cases of the entire 20th century, the 70-year-old mystery of the Somerton Man. For decades, this case seemed practically impossible to solve, but we're going to unravel it together by looking at how two completely different scientific approaches, cutting-edge data science and modern genetic genealogy, finally combined to crack a mystery that stumped the entire world. Okay, let's dive right in. So, to understand why this case is so incredibly famous, we really have to start with the central question. Who actually was the Somerton Man? Picture this. A man is found dead on a public beach. He carries absolutely no identification, nobody ever comes forward to claim him, and yet he's surrounded by a trail of highly specific, almost cinematic clues that seem to point everywhere and nowhere all at once. It's the ultimate knowledge gap, and it has obsessed amateur sleuths and professional investigators alike since the mid-20th century. The story begins on the morning of December 1st, 1948. A guy is found deceased on the sand of Somerton Beach in Adelaide, Australia. He appeared to be in his mid-40s, physically fit, and strangely enough, he was dressed in a full formal suit with a tie and polished shoes, which is hardly typical beach wear, right? But here's the kicker, the detail that immediately set off alarm bells for investigators. Literally every single identifying label on his clothing had been meticulously cut out and removed. I mean, who does that? Part 1. The Tamám Shud clues. Well, those missing clothing labels were just the tip of the iceberg. During a thorough examination of the man's clothing, police discovered a secret, hidden fob pocket sewn right into his trousers. Inside this tiny pocket was a tightly rolled, wrinkled scrap of paper. Printed on it were just two words, Tamám Shud. It's a Persian phrase that translates to, it is ended, or finished. And get this, investigators quickly realized this exact scrap had been torn from the final page of a rare edition of the Rubaiyat of Omar Khayyam, which is a 12th century book of poetry. And thanks to a massive public appeal, they actually found that exact missing poetry book. Someone had just tossed it into the backseat of an unlocked car parked right near the beach. But wait, it gets weirder. Police also tracked down an abandoned suitcase at the local railway station. Inside was a coat, shaving gear, tools, and strangely, the suitcase and a few items inside were inscribed with the name T. Keane. Yet no missing person by that name matched our victim. And the absolute cherry on top? The back cover of that recovered poetry book had a local phone number scribbled on it, along with faint indentations of what looked like a strange handwritten code. Now, what's really interesting about this slide is the sheer visual puzzle we're dealing with. On the left, we have the fateful Tamám Shud scrap, and on the right, that mysterious handwritten code found on the book. It consists of 50 capital letters arranged in somewhat irregular lines, with some of the letters completely crossed out. For decades, the Australian Department of Defense put their absolute best cryptographers on it, but they eventually just declared it practically unbreakable. They figured it either lacked sufficient symbols to decode, or it was simply the meaningless scribbles of a disturbed mind. Part 2. Cracking the code. But you know science, it absolutely hates leaving a puzzle unsolved. So decades after the military threw in the towel, Professor Derek Abbott and an academic project group from the University of Adelaide decided to take a fresh look. They realized something crucial. Instead of trying to manually guess the meaning of the letters, they could apply modern statistical data analysis to at least figure out the underlying language and structure of the code. They set out to systematically compare the 50-letter code against massive data sets of text in tons of various languages. To pull this off, they used a couple of really specific algorithms. The first is a concept from information theory known as the Levenshtein distance. In plain English, it's basically an edit distance. It mathematically measures the difference between two strings of text by calculating the absolute minimum number of edits you need to make to turn one word into another. It's a remarkably precise way to computationally figure out how similar two pieces of data actually are. Let me walk you through the exact example the researchers used in their thesis, just to make this super concrete. Say we want to transform the word intention into execution. To do that, we have to make exactly 5 edits. As you can see, it requires 3-letter substitutions, 1 deletion, and 1 insertion. By running these kinds of mathematical calculations across thousands and thousands of text samples, the researchers could statistically compare the Somerton Man's code against different world languages to see which one it fit best with the lowest edit distance. But they didn't stop there. They also brought in a second algorithm called SimHash. This is actually a brilliant technique originally invented to help companies like Google spot near duplicate web pages across billions of documents. For this project, the researchers chopped the text into tiny 2-letter chunks called 2 grams, applied a mathematical hash mapping to them, and squished them down into a final digital fingerprint. Then, they simply compared the fingerprint of our mystery code against the fingerprints of books written in English, French, Italian, German, you name it. So what did all this heavy-duty data science actually tell us? Well, the academic tests were incredibly revealing. They confidently concluded that the code is definitely not random, and it is not some complex one-time pad encryption used by international spies, which was a huge theory for years. Instead, the statistical structure strongly indicated that the letters were English initialisms, meaning each letter is simply the very first letter of an English word in a sentence or a list. Part 3. The DNA breakthrough. Let's move to and see how this builds a concrete identity. Data analysis gave us the framework, sure, but it still didn't give us a name. To get that, we have to pivot to biology. Looking at the timeline here, way back in 1948, investigators made a plaster death mask of the victim's face, and completely by accident, a few strands of the man's hair got trapped right in that plaster. Fast forward over 70 years. Thanks to some absolutely incredible advancements in biological engineering, Professor Abbott and American genealogist Colleen Fitzpatrick managed to extract viable DNA from those rootless 70-year-old hairs. Plus, in 2021, the police finally exhumed the body for further testing. Now, before we reveal the identity they uncovered, we absolutely have to talk about the massive red herring that derailed amateur sleuths for literal decades. It involves a local nurse named Jo Thompson. She's the woman whose phone number was found scribbled on the back of the poetry book. See, Jo Thompson always swore to the police that she had never met the victim, but people were incredibly suspicious. Why? Because Thompson's son, Robin, shared some insanely rare anatomical traits with the Somerton Man, specifically canines positioned right next to the front teeth and a highly unique ear structure. These traits pop up in less than 1% of the entire population. So to everyone looking at this, it seemed painfully obvious. The Somerton Man had to be Robin's secret father. But the DNA verdict? Completely unambiguous. There was absolutely zero genetic relation between them. Those shared ultra-rare physical traits were quite literally just a staggering freak coincidence. Part 4. Meet Carl Webb. With that giant red herring finally out of the way, the genealogical mapping of the extracted DNA led straight to one distinct family tree. We can finally put a real name to the face. His name was Carl Webb, though he usually went by Charles. Born in 1905 in the Australian state of Victoria, he was an electrical engineer by trade. And once researchers started digging into Webb's biography, all those bizarre puzzle pieces just instantly clicked together perfectly. Remember that abandoned suitcase inscribed with T. Keene that completely baffled the police? Well, it turns out Carl Webb's sister happened to be married to a man named Thomas Keene. The victim was literally just using his brother-in-law's old hand-me-down luggage. So the really crucial point here is how this new biographical reality totally reframes that mysterious code. For decades, the public was absolutely convinced this was an elaborate, unbreakable spy cipher. But Webb's friends and family noted two big things about him. He loved writing poetry, and even more so, he loved betting on the horses. Now, think back to the data science conclusion. English initialisms. Yep, you guessed it. That highly sophisticated spy code was almost certainly just Carl Webb jotting down the first letters of horse names so he could keep track of his bets. And this brilliantly illustrates how the most baffling, cinematic clues can actually have incredibly mundane explanations once you just have the right context. The T. Keene suitcase? A family hand-me-down. The unbreakable spy code? Just a gambler's shorthand. And the reason nobody ever came looking for him and no true identity was found back then? It was simply because Carl Webb was estranged from his family, and he never actually left behind any official documentation of his death. Science really is an incredible tool. Through data analysis and genetic genealogy, we were finally able to answer exactly who the Somerton Man was, effectively closing the book on his true identity. But as satisfying as it is to finally put a real name on his gravestone, the final piece of the puzzle is actually still missing. We know who he is, but we still have absolutely no idea how or why he died. The original 1948 autopsy showed that Carl Webb suffered from severe internal bleeding right before his death. Pathologists at the time strongly suspected he had been poisoned. But here's the crazy part. They could never find a single trace of any known toxin in his system. Was it a suicide, maybe hinted at by the gloomy, finished poetry he carried in his pocket, or was it an entirely untraceable murder? The South Australian police investigation formally remains open to this day until they can definitively determine the actual cause of death. We know his name, we know his habits, and we know for sure he wasn't some international spy. But the human element, that remains a total ghost. Why did an electrical engineer from Victoria travel all the way to a random beach in Adelaide, meticulously cut the tags out of his own clothes, and pass away with a scrap of 12th century poetry hidden in a secret pocket? It's a stark reminder that while science can map our DNA and decode our writing, the secrets of the human heart are much, much harder to crack. Thanks for joining me on this explainer, and I'll see you in the next one.